This is notes for the assignment 43, concavity. And we already kind of talked a little bit about what concavity means. Last class period, we said that the concavity is how the graph opens. It either is going to open upward. If it's concavity, if it's concave up, that means that the graph will be pointing up. All of the tangent lines on the if the graph of f lies above all of the tangent lines on the interval, then it's concave up. And we know the tangent line is the lines that touch at one point. Notice that all of those lines are below the curve. So that means that it's concave up. Same thing for concave down. If the tangent lines are above, that means, and basically it's saying how the graph is pointing. If it's going to open upward, it's going to point up. If open downward, it's going to point downward. And we talked about the different types of mins. We talked about absolute mins, local mins. It's the same thing with max, absolute max, local max. One thing we need to talk about is points of inflection. Points of inflection is where the concavity changes, where the point where it changes from concave up to concave down. So if you look at this little picture, this first point, well, let's label all the points. A, B, C, D, E, F, G, H, I, J. Okay. So the first point A, it's low, but it's not the lowest point. So it's neither it's not an absolute min. It's not even a local min. So it would be that in that neither category, right? Point B, as you can see from A to B, it's concave down. My tangent lines would be above. But once it passes up to point B, my tangent lines are below. So point B would be a point of inflection. Okay. Point C, of course, I'm coming up to a maximum. It's not the highest point. It's not as high as point I here. So it's not the absolute max. So it means they're using the word relative that's the same as local. Local and relative is the same thing. Their words are interchangeable. Point D, if I look at point D, it's before point D, the tangent lines would be below the curve, so it's concave up there. And after point D, same thing, the tangent lines are below, so point D is not an important point. It falls in that neither category. Point E, as we can see, it's at that hump, so that's a minimum. It's not the absolute minimum because it's not lower than point G. So we kind of understand in that. Well, let's look at some graphs. And if I was to ask, okay, where's my absolute minimum, max, local mins and max, and points of inflection? All right. The easiest things to find right offhand would be the local mins and maxes. And we're to assume that these graphs are going on forever. So at those humps, I know that this point here represents the local max, right? So I got a local max at, I believe that's x equals 0. And here I have a local min at x equal 1, 2. Looks like it's 1, 2. Looks like it's 2. All right. Now, do I have any absolute maximums and mins? Well, if I look, the graphs are extending. On the right-hand side is extending all the way up to infinity. On the left-hand side, extended all the way to negative infinity. So that means that it's going on forever. So there will not be any place where it's going to stop and be the highest point. So I have no absolute no absolute mins nor maxes, right? So what about points of inflection? Well, it's concave from x equals 0 on back. It's concave down because all of the tangent lines are below. After 0, it's still concave down until it gets somewhere around here where the concavity changes, and I believe that's at 1. If you look at x equal 1, all the tangent lines are above the curve, but once it gets past 1, the tangent lines are below. So 1 would be, so I have a point of inflection at x equal 1. All right, do I have any other place where that happens? Once I pass up x equal 2 here, still concave up because all my tangent lines. So I only have one point of inflection, and that's x equal 1. So y'all should be able to do the bottom two on your own. Let's look at this particular problem right here.